Another concept that would use the idea of derivative of a complex function is what we call as the L'Hopital's rule. This rule is actually on the identification of a limit of a complex function whenever our complex function, when a certain value is being approached to, would actually create a value equivalent to either 0 over 0 or infinity over infinity. These two are what we call as indeterminate forms. Actually, there are just two of those indeterminate forms, and we cannot have these two forms in the realm of the mathematics. That's why they're called indeterminate form. That's why we're going to use a certain process that will allow us to really solve for the limit of a certain function no longer equivalent in these two forms. Now, this is actually possible if there is a limit, okay, of a certain function, let's say f of z over g of z, as z approaches to a certain constant. We know that one of the rules that would allow us to solve for the limit is direct substitution. But whenever we are going to substitute that c, it would either result to 0 over 0 or infinity over infinity. Okay, so that is why we are going to use here the L'Hopital's rule. The L'Hopital's rule allow us, or will allow us to solve for the limit after using the concept of derivatives. Now, let me write here the definition of the L'Hopital's rule before we could actually use it on some situations or illustrations later on. Allow me to use this definition here. So, suppose, okay, we have here, suppose f and your g are functions that are differentiable. Okay, so it is identified that they are both differentiable at a certain number, on, let's say, on an open interval, okay, containing your c earlier, c, of course, except possibly at c, because that is the idea of the limit, right? And here comes the concept, and that if we're going to take the first derivative of your denominator, which is still not equal to 0, for all z in your open interval, let's say I, of course, except possibly at your c. If these are actually considered to be true, or it would hold for the situation, okay, even if they will result to this, the L'Hopital's rule will then be, or can be used later on. Of course, just to complete this, okay, and we're going to connect this idea here, and that your first situation, the limit of your f of z as z approaches 0, and the limit of your g of z as z approaches 0. By the way, I forgot here, is equal to 0 and is equal to 0, thereby making the indeterminate form 0 over 0. Okay? Or, your second situation, the limit of your f of z as z approaches 0 is infinity. And that is also the same as the limit of your g of z as z approaches 0, infinity, thereby making the second indeterminate form infinity over infinity. The L'Hopital's rule tells us, okay, if the limit of your, let me say here, if the limit of your first derivative of f over the first derivative of z as z approaches the same c, by the way, this is no longer 0, this is actually c, pardon, I was thinking earlier about zeros, so you have here c, and then c here, okay? If the limit of the derivatives of both functions exist, and then again, the g of z is not equal to 0, okay? Then, we can now say that actually, the limit of the given function, the original function, where supposedly would be indeterminate as z approaches the certain value of c here, would just be equal to the limit of the ratio or the quotient of the derivatives of the two functions, still the same as z approaches c. Okay, so this is the L'Hopital's rule. It tells us that if, when we used c, it would have 0 over 0 or either infinity over infinity. The idea here is, again, identified that they are both differentiable. Okay, we just need to take the first derivative of the numerator and the first derivative of the denominator, provided that this is not equal to 0, and we're going to take the ratio of them, subject it to the same idea of c as z approaches c. The limit for this is just the limit of the original function. Okay, so this is the L'Hopital's rule. We will have some illustration for it later on, and of course some items or identities that we have used previously will also be verified using the L'Hopital's rule. But this is the L'Hopital's rule in its essence. Thank you very much for watching.